So we've done detailed measurements of the key value store, and so on the key value store we can measure the latency within the chip, the latency going out to the interface, the latency going out to the network, and the latency going out to the end host that's processing this. And so that the fastest latency, of course, is the on-chip latency. And so in our case, that the on-chip latency, it can be measured in nanoseconds, is that our lookup engine can resolve a key value pair in about 200 nanoseconds and give a result back to the FPGA logic that's inside. Slightly longer is the time to package up the IP packet where it came in. So we have an FPGA networking stack that offloads the encoding and decoding of the packet to FPGA logic. And so we can get back out to the SFP plus interface. So this is the interface to the card. And we can see that the measured latency on the wire is the 0.467 nanoseconds. So that's the time from the cross-section of the card for packet to come in to the FPGA, get processed, and go back out. So the key value store can scale out, and so if we look at, in the limit, how fast we can make the key value store, is that with a 40 gigabit Ethernet connected to the key value store, that we can do 150 million IOPs on each of the key value store cards. So with 40 cards that are in a rack, which would be standard for a rack mount system, that would give us 6 billion IOPs per rack of operations that we could do with these 40 key value store cards. Now the bandwidth with 40 gig Ethernet running at line rate on all 40 cards is 1.6 terabits per second per rack. The latency remains unchanged. In the 40 gig version of the key value store, the latency is 342 nanoseconds. And so that sub-microsecond latency is preserved across the cards. And then for programming, the programming model is unchanged. As the key value store, just doing standard Ethernet read and writes to the switch, are being distributed out to the key value stores that are in the rack. And so we have open source API so that you can do create, insert, modify, delete key value pairs from any software stack, C stack, Python, Java,